Hello everyone. Today we will discuss about the serial communication in 8051. There are two important registers in 8051 that are used for serial communication. One is SCON, another is SBUF. Now SBUF is the placeholder for data to be transmitted or received. Okay, and SCON is used to set the mode of the serial communication, as well as to flag whether the transmission is complete or whether the reception is complete. Now let us see the SCON register in bit detail. The first two flags, SM0 and SM1 flag, are the bits used to set the mode of the serial communication. If it is 00, then it is the mode 0, that is a synchronous mode where the baud rate is equal to f oscillator divided by 12. If it is 01, then it is the 8-bit UART mode with a variable baud rate, and the baud rate is set by timer 1 register, which is in mode 2. Okay. Now when SM0 and SM1 are 10, then it is the 9-bit serial communication mode with the baud rate of f oscillator divided by 64 or f oscillator divided by 32. So when it is 11, then it is in mode 3, it is a 9-bit mode with a variable baud rate. SM2 is used for multiprocessor communication. REN stands for receive enable, and TB8 and RB8 are used to transmit and receive the 9th bit. So we know that SBUF is the 8-bit register. So if the serial mode of communication has to operate in 9-bit mode, then SBUF will contain only 8 bits, and the 9th bit mode is set in TB8 when you want to transmit the data, and the 9th bit is received in RB8 when you are receiving the data in 9-bit mode. Okay, and TI and RI are the interrupts that say whether the transmission has completed or whether the reception has completed. Now let us go in detail with the serial communication mode. When we are using serial communication mode, we come across the important word called as baud. Now, what is a baud? Baud is nothing but number of bit that is transmitted per second. Okay, so how do you calculate the baud? Now in 8051 we have a crystal oscillator that is divided by 2, that gives you a machine cycle frequency. That divided by 32 gives us a UART frequency, which is used to run the timer. Okay, so that sets the UART frequency will be used by the timer to set the baud rate. Okay, now if the crystal frequency is 11.0592 megahertz, then the machine cycle frequency is 921.6 kilohertz, and the UART frequency is 28,800 hertz. Now let me take a calculator, and let me say that if I have to generate a baud rate, then with the UART frequency of 28,800, and if I want to generate a baud of 9,600, then I need to have my timer 1 increment by a factor of 1 minute. It is in hexadecimal mode, sorry. Okay, so if I have a UART rate frequency of 28,800, and if I want to generate a baud rate of 9,600, then my timer 1 should increment by a factor of 3. That means my timer 1 has to be loaded with the value called FD, because I have to work backward from FF. So the formula is FF minus increment plus 1. So FF minus 3 plus 1 gives you FD. Okay, so let us go to the next page. In the next page you will see the formula for calculating the baud rate. Okay, so the baud rate is given by the formula 2 to the power of S mod divided by 32 into oscillator frequency by 12 into 266 minus TH1. So let us assume initially that S mod is equal to 0. Now this S mod flag is in PCON register. Okay, let us assume that S mod is equal to 0. 2 to the power of S mod 0 is equal to 1. Okay, so at that time the oscillator frequency divided by 12 gives me the machine cycle frequency, and then machine cycle frequency divided by 32 gives me the UART frequency. So if I want to generate a baud rate of say 9600, then this factor should be 3. Okay, so that means 256 minus TH1 should be 3. Why is it? Because it is 28,800 divided by 3 is equal to 9,600. So if you see this table, for 9,600 my TH1 should be minus 3, or my TH1, if I work backward from FF, then TH1 should be loaded with the value FD. Okay, so similarly, if I want to have a baud rate of 4,800, then TH1 should be loaded with either minus 6 or FA. Now this particular values is true if and only if S mod is 0. Okay, if S mod is 1, then it's going to be half the value. Okay, now let us go to the Keil and let us see this particular program and explain about this particular program. Okay, now in serial communication we will be using timer 1, and the timer 1 has to be set in mode 2. Okay, so now in this particular case I have set the timer 1 in mode 2, and timer TH1 I have assigned it to FDH. Now FDH stands for a baud rate of 9,600. Okay, now so TL1 also I am initially loading to FDH, and SCON I am setting it to 50. Why is that? Because SCON being 50 translates to 0 1 0 1 0 0 0 0. So SM0 and SM1 are 0 and 1, so that means it is in the serial mode communication 1 and receive is enabled. So serial mode communication 1 stands for 8-bit mode. Okay, so let us go back to the Keil. Okay, and let me see what happens. So after setting the SCON register, I am running the timer, and then I am sending A to SBUF. That means I am putting A to SBUF, and then I am looping till my transmission has completed successfully. Okay, so now let us see what happens when you are passing A to SBUF. A is a alphabet, so basically the ASCII code of A will be put in SBUF. Okay, so let us now compile this particular program. Okay, and then I am going to put this session in the debug mode. Okay, now here what I am going to do is, in the serial window, if you see there is a UART. So if you see here there is a UART. I am going to click on this. When I click on this, it will open a UART panel in the bottommost location. So UART 1. Okay, so this is where your data will be displayed, because this is a simulation environment. So the program will put the whatever the value that is transmitted serially to this window. Okay, so now here we are transmitting the character A to the SBUF, and we are transmitting it out serially. So we expect A to be displayed in the UART panel. Okay, now at the same time I am going to open few other peripherals. One is timer 1 and another is the serial channel. Okay, so let me let me run the program stepwise. So initially my timer 1 will be going to mode 2. So it is a 0x20, that is a timer 1 being in 8-bit auto reload mode, and timer 1 will be loaded to FD, TH1 and TL1. Now SCON will be loaded with 50. The moment I load SCON with 50, so if you see here it has changed to 50, and it has changed to 8-bit variable baud rate. Okay, so I will run the timer now. Okay, So if you see, the moment I run the timer, the baud rate is set to 9600. Why? Because the timer 1 I have set to FD, that corresponds to baud rate of 9600. Okay. So now let me run further. I am moving A to SBUF. What is the value of A in ASCII? It is 41, 0x41. Okay, so SBUF here should contain 41 after I execute the next step. So if you see, SBUF contains 41. Okay, and then it will loop indefinitely. So I am going to run this particular program. Okay, so if you see here, it has transmitted the value of SBUF serially to the UART console. Okay, and then subsequently it has cleared. Okay, so that is about this particular example. Now, having worked on this problem, let us now explore how to transmit a string of data serially. Okay, so what I'm going to do is I'm going to tweak this particular program to send message hello. Okay, so initially I will be setting the SBUF to H. Okay, and then I will be setting the SBUF to E. Okay, this is a crude way of doing it, not the right way though. Okay, and then I will be setting it to L, L, O. Okay, so let us do this way. H, G, L, L, O, O, and we have to rename the labels. Okay, because duplicate labels are not allowed. Not the right way though, but let us see. Okay, okay. So we have what we are doing is we are setting H to SBUF. Okay, and then we are waiting for the transmission to be completed, and then we are clearing TI, and then setting E to SBUF and transmitting it serially. Then we are setting L to SBUF and then transmitting it serially. So we are sending it character by character at a time. Okay, let us compile this particular program. Okay, and let me put the session in the debug mode. Okay, okay, okay. So again I will run it stepwise. Initially my tmod is going to be in mode 2. Timer 1 is going to be in mode 2. Okay, and then I will load the preload and as well as TL1 to set the baud rate to 9600. Then I will set the serial mode communication 8-bit UART mode. Okay, with receive enable, and then I will run the timer. So the baud rate is set to 9600. Now I will run the program, and you will see in the UART console that I have got HELLO. Okay, so this is the way if you want to send across message string serially, you can send character by character. Okay, so but this is not the right way. So the best way to do it is you define a subroutine called as say xmit. Okay, and you put these values in the subroutine xmit. Okay, okay, and toward the end of the xmit, you have to toward the end of the subroutine, you have to always write a return statement. So I will call xmit everywhere instead of coding this. Let's say a call xmit xmit Okay, so I'll remove this label also, it is not needed. So first you assign a character, then a call xmit, then assign the second character and say a call xmit, then assign the third character and say a call xmit, and assign the fourth character, assign the next character and say a call xmit. So I'll copy this and replace it everywhere. Okay. Now let us see what happens. If I let me compile this program. Okay, there is a error, undefined symbol. Let us see, where is it? Line number 18. Line number 18. Xmit, a call xmit. Okay, xmit. Okay, loop 2 is not defined, so that's the reason. Okay, so let me rebuild the project. Okay, and let me put it in the debug mode, and let me run the program. So if you see, it has transmitted the string hello serially to the UART. Okay, basically this is the preferred way, primarily because you avoid the duplication and put the duplicate code, whatever is being reused, you put it in a subroutine and you call those subroutine from every corners of the program. So this is the preferred way of doing things. Okay, now we will see a program to receive the data serially. So to start with, again say include reg51.h, then void main void, then open the flower bracket and close the flower bracket. Okay, and inside this set the timer mode to 20, that is timer 1 in mode 2, and set th1 is equal to 0x fd for the baud rate of 9600, and tl1 to 0x fd for the baud rate of 9600, and then we will set scon to 50 hexadecimal. That is it is a serial mode communication. The mode is 1 and the REN flag is set high, and then we will run the timer. So I'll say T R1 is equal to 1. Okay, and now our objective is to receive the message. So what I will do is we have to check the receive interrupt flag. Whenever the receive interrupt flag is high, that means a message has been received. Okay, so I'll say while Ri equal to 0, then loop within itself. Okay, and if once the Ri becomes 1, that means the data is available. So if the data is available, I will transfer that to port 0. Okay, so I say P0 is equal to sbuff. So once the data is available, so the data will be available in the sbuff. So I will transfer it to port 0, and then I will clear the receive interrupt flag. Okay, so that is about the program. So let us compile this particular program and see if there is any error. Okay, there is no error, and let me go to the debug mode. Okay, and I will open the port 0, okay, because I want to see what the port 0 has received. Okay, so so when I run this particular program, and if I enter a character in this UART window, that ASCII value of the character will be visible in port 0. Okay, so let me step through initially the program. So tmod is 020, it is in auto reload mode, and th1 and tl1 are set to FD, and scon is set to 0x50. okay, and the baud rate is not yet set. Once I run the timer, the baud rate is set to 9600. Now let me run the program. So the program is expecting some character to be received. So I'll send the character capital A. Okay, the moment I send capital A, so if you see, the port has changed to 41. So the ASCII value of A is 41. If I type B, now whatever I am typing is not visible in the UART screen. Okay, so if I type B, so if you see here, it has set to 42, and if I set small a, so it has set to 61. So I am receiving the UART, I am receiving the serial message from the UART, and that particular program is getting the SBUF and setting it to port 0. Okay. Now I will do the same thing in assembly. Okay, so I'll discard this C program and I'll write an assembly file. Okay, and I'll say that serial CRIAL RECV dot A51. Okay, and in this I will use the same mechanism. So I will say first start start move tmod comma hash 20 hex h. Okay, then move th1 comma hash 0 fd h, move tl1 comma hash fd 0 fd h, scon move scon comma hash 50 h, and set bit tr1, then jump on no bit. Okay, we have to check receive interrupt, so jump on no bit receive interrupt LOOP. So I will name this particular location with I'll set the label for this location as loop. Okay, okay, so once the receive interrupt is flagged, then I will say move p1 comma p0 comma sbuf, then I will say clr ri and end. If you see the structure of C program and the assembly, they are same. In the C program we are setting tmod 0x202 tmod. So I am here moving 20h to tmod, and then th1 is set to fd. So th1 is set to fd and tl1 is set to fd. In the assembly now tl1 is set to fd. Then I am setting scon to 50 in C. Similarly, I am setting scon to 50. Then I am setting 1 to tr1. So the way I do it in assembly is set bit tr1. Then in C program I will say while ri equal to 0. So in assembly I am saying jump on no bit ri comma loop, and then I am saying p0 is equal to sbuff. So in assembly I am saying move p0 comma sbuff. Then in C program I say ri is equal to 0. Here in assembly I say clear ri. So almost whatever I am doing in C program, there is a one-to-one mapping in the assembly program, but only thing is the syntax is different. Okay, so let me compile this. So there are no errors. Now let me debug this. Okay, and now let me run this program and let me press capital A in the UART terminal, and please observe the value of P0. So the ASCII value of capital A is 41. Okay. When I press capital A, so the value of P0 has changed to 41. Okay, so this is the way the serial communication receive program will work.